In this video, I'm going to be looking at the DUT Control Interface feature of the M8070B software. This allows you essentially to bypass the error detector, or what you would normally use as the error detector for your bit error rate data, and use the internal bit error rate counter on your own device. What we can do is add some hooks to directly pull that data into this M8070B software and use that as the data error source. I'm going to show you how to do this using the serial port and also using sockets over Ethernet. Let's get started. What I have here is the M8070B software. I've got the module view open. I'm running this in simulation. We can do this in simulation. We don't need an actual instrument with us. And in simulation mode, it will just bring up some kind of fake devices here. And we'll know we're in simulation mode when we're looking here. It's actually not really connected. That's a generated clock, that sort of thing. Now, when you're going to do error ratio measurements, normally what you would have is your M2 data in. That would be your physical module, your hardware error detector module. When I go to run a error detection on this, we'll be plotting values here, and they'll be plugging along so forth like this, and that will be coming from the hardware error detector. But what we want to do is not use that as the data source anymore. We're going to be plugging that in. What I do have here is an Arduino physically connected up to COM9. So I've actually turned that on. Let's pull up the code here and just look at what this is doing. This is going to simulate what your device would put out on if you're using a serial port. If you're familiar with Arduino code, it looks like C. We initialize the serial. We've got it set at 9600 baud. And we are running a clock interval, a particular rate, and then we're basically looking for strings that are coming in on the serial port, and we'll respond to them. So what we're going to have the M8070B software do using the DUT Control Interface is actually put messages and retrieve messages on the serial port that they're both connected to. So that is one way we can do this. I can go in here and load up COM9, for instance. This is already running. And if I type the H command, I get a list of things I can do. Generally, once everything's set up for the purpose of simulation, if I press C, I will get an error ratio of some sort based on how I set it up. So you get a bit count and then an actual value that comes back. And this is fictitious values that look like what would come back from a real device. And this is just to demonstrate the purpose. But with your device, you would be pulling these in, and you'd have some synchronization. When the data is ready, it would give it back. In order to get this turned on, we can go to the DUT Control Interface. Under Utilities, I can import or open something that I've already created. So I have the Arduino DUT example. If you already have, this is one you probably would want to start with. So you'll make your changes, and before you can run it, you need to save it. Now, there's a few things you need to do. Number one, if we want to run this, we can't run it just yet. We can't start the script because there's two things we have to do. We have to install it, and then we need to connect it over here in the DCI control. So once we do that, if we go back to the error ratio view, we now see that we have a choice of DCI lane 1 versus M2 data in. And when we do that, this is now the data source. So we should be able to see what's being generated on the Arduino. This is being generated by the Arduino, some fictitious error data that's coming across, and that's what we want to do. So we've made a physical hardware connection. And I think the next question you're going to ask me, what's going on in the code? So let's go back out. Let's go back to the DUT example. First of all, this is using IronPython 2.7 on the BERT side. That's just what's implemented. It's a .NET-based Python, very easy to work with .NET APIs, and that's exactly how it's being used. It's a very simple interface. So if I want to cut and paste or alter this right now, if I wanted to say control or copy, it's going to give me a warning, cannot do it in connected mode. You want to disconnect? Of course. And you can connect and disconnect this way as well. But make sure when you do connect that you go back to the connection knob. That switch doesn't go right away. There's a couple of some housekeeping. Import the DLLs that are required. Import the M8000 API. A very old version of this used to be called Agilent series. So you should be using the Keysight series, probably not an issue these days. One of the most important, there's a handful of functions here. There's DUT connect, DUT disconnect. In this case, we've defined the serial port here. The DUT connect gets executed when we make the connection. The serial port will attach. You will probably have to change this to the COM port that you're using. And then you'll have some serial port baud rate information you have to put in here, and also the read timeout and the write timeout. So these have to, usually 500 milliseconds will do it. Sometimes there's some comms errors that you have to fix that. And this allows us to, remember in the Arduino code, we have the option of setting a base bit error rate here, like the BER, these commands. So this is this actual command, B and 4E2 to the -9. That's just set kind of the base level for the bit error rate tester. This is again for simulation. If you need to send some commands to your device at this point, you may want to do it on opening. This is on connect only. This will be run once. To disconnect from the DUT, we've got DUT disconnect. It's pretty self-explanatory. If the port is open, it will disconnect, close the port, and then dispose of it. And then get locations. This is what our channel will be called. So what's the most important here is what we're trying to get is the DUT get BER location. We use a global variable serial port and BER counter. This is the serial write line again. So in the Arduino code, in this case, we chose to use C as a command. You could use whatever you want in your device, but this will get the counters, the number of bits and the errored bits. This is where it grabs the data. It does the read the line and then assumes that it's coming back correctly, and then it splits on the comma, and then it will put the delta bits and the delta error and then feed that back to the software. And that's as simple as it gets. When we have that running, again, with the Arduino code, and I can make that available in a package online, I'll put a link to it in the video. We can do an install. We connect here. We go to the Arduino DUT example here, and we can go to error ratio. We make sure that we've selected not data 1 in, but now our DCI in, and now we're running this data set here. And that's pretty much it for running it with a serial connection. The next thing I'm going to show you is how to do it with a socket connection to a different application that's running. And we'll get right to that. Okay, in this section, I'm going to talk about using sockets now. So we want to go over Ethernet. So your DUT you may want to run that over Ethernet and then connect into your device. You may have a method of connecting through sockets, and that's what we're going to look at next. I have loaded my example. If I wanted to open that up, I've called it fake data 1 or something like that. So anyway, I've loaded it up. And if we look at the sockets code, it's the same, except we're using sockets. So we need to put the extra modules. We need to import sys socket, maybe math, a few other things. The idea here is that you want to put the address for the device you're talking to, so your DUT per se. This is what mine looks like. So this is what would you call it? It's a fake DUT is what you want to call it. What we can do, so I've just rearranged this so we can see what our DUT looks like. So this is somewhere on the network. This just happens to be a local address, but I can put that pretty much anywhere. And just as long as I have access to it, there's no firewall issues, things like that. So just be aware of that. That's pretty common stuff to common knowledge. So I put that address that's here. This is waiting for the BERT to connect. So it's listening for the socket. And when we do make a connection, it will connect. We have the ability to connect to that, send command to DUT and receive response. So that's one of the commands. So here's our DUT connect. That's where we need to go. DUT disconnect is similar to the way we implemented this serial port. And DUT init, you may have an initial init command as well. So that initialize according to the given argument. So what we want to do is receive data, receive response, get DUT BER, and then we'll come back with compared ones, compared zeros, zero ones, and more information in this particular case. But this is where the data comes back. I'm going to make a link provided to this code. So if you want to start with this kind of template, that's a good way to go as well. There's other ways of setting target jitter and things like that you can send back to your device as well. So I'm going to run this. I'm going to make the connection like before, and then we're going to make the connection. As soon as we hit connect, we're going to watch and waiting here for BERT to connect. And there you go, connected to the BERT at this address. We're good to go. And if we go back to error ratio, for instance, and we want to check that selected, and when we run this, it's going to get a BER. See this orange line down here, and I'm going to insert an error. I clicked it, clicked a bunch of times, kept it up there. That's what happens. I can also, in this particular software, generate a regular 1E -8 with some data fluctuating around that. But this gives you the idea. You can change. This software is just available if you want to do a sanity check on your system first, which I highly recommend that you do. Just makes things setting up easy. You start with this and then modify that code. So that's how it works, and a little quick overview of how to deal with that. The other thing just I wanted to mention, if you want to go to, say, a jitter tolerance, let's go measurements, for instance, your data source here. If you go to anything that uses, for instance, a BER setup here, target name, BERT setup, confidence level, instruments. In the instruments, M1 data out, DCI lane 1. So if you're doing JTOLs, you can control it with JTOL. You're going to have more handshaking, more synchronization, but yes, it is possible. And again, your analyzer is the DCI1 lane source. So that's it for the DUT Control Interface primer, how to get started, how to get programming that. If you like videos like this, you want to see more of them, don't forget to like and subscribe. And if you have any questions, post them and I'll see if I can get back to you on those. Thank you very much for watching, and keep on testing.